So when is a bleed more than just a simple cut? When does it become truly life-threatening? In the movies, it's always super dramatic, right? But in the real world, the difference between a manageable injury and a fatal one actually boils down to a couple of key principles, and we're going to break those down right now.
Okay, let's jump right in with a question that frontline responders have to answer in seconds. Just look at these 4 different injuries. Which one of these do you think would be the toughest to get under control? You've got different arteries, a vein, and all different blood pressures. Take a second, think about it. Because by the end of this, you're not only going to know the answer, you'll know exactly why. To figure out that puzzle, we've got to understand the basic physics of bleeding. And what's really fascinating is that the severity of pretty much any external bleed boils down to just 2 main things. Yeah, it's a surprisingly simple formula for what can be a super complex and scary problem. And here they are. First up, the size of the blood vessel. Think of it kind of like a garden hose versus a fire hose. The bigger the pipe, the more fluid can gush out at once. Same thing here. A bigger artery just means a bigger potential for massive blood loss. And second, you've got blood pressure. This is the force pushing the blood out. The higher that pressure, the more violently the blood is going to escape. So what's the big takeaway? The absolute worst-case scenario is when you get both at once, a huge vessel combined with crazy high pressure. All right, so we've got our 2 golden rules, vessel size and blood pressure. Now, let's go back to that first question and apply what we know to see which one of those injuries is the real monster. So let's break it down. If you look at options A, C, and D, they've all got something that kind of limits the severity. Either the vessel isn't that big, or the blood pressure is low, or it's pretty much normal. But then you get to option B, and whoa, that one has 2 huge red flags. You've got the femoral artery, which is one of the biggest in the body, and a blood pressure of 160/90. That's hypertension. That's high. It's the only one that has that really dangerous 1-2 punch.
And boom, there's our answer. It's B. The combination of that huge artery and that super high blood pressure creates an absolute nightmare scenario for bleeding control. But what is it about the femoral artery specifically that makes it so bad?
Okay, so we've zeroed in on the femoral artery, but what makes this particular blood vessel such a major threat? Let's zoom in a little bit and look at the anatomy. And check this out. This detail from the source material really puts it all into perspective. The femoral artery, the main artery running down your leg, it's nearly the diameter of your pinky finger. Just take a second and imagine that. A hole in something that big isn't just a leak, it is a full-on catastrophe. So you've got this massive opening in one of the body's biggest pipes, and you're combining that with hypertensive force literally blasting the blood out. It's a perfect storm. Massive volume plus intense pressure. That's what creates the most difficult, the most dangerous kind of external bleeding you can face. But you know what? This brings up a really fascinating and, frankly, a very dangerous twist. It's what we call the hypotension paradox. And it's a situation where something that looks like a good sign is actually a terrible warning. I mean, it makes perfect sense, right? If high blood pressure is bad for a bleed, then logically, low blood pressure, or hypotension, that should be a good thing. And, on the surface, it is. As that pressure drops, the force behind the bleed weakens, and it slows down. It becomes easier to control. It really seems like things are getting better, but they're not. And this is where everything gets flipped completely upside down. Because in a major trauma situation, that drop in blood pressure isn't a sign of recovery. As the source material says, it's very unfortunate, and there is a critical, life-or-death reason why. See, that low blood pressure is actually a sign of something called decompensated shock. It means the body has lost so much blood that it just can't keep up anymore. Its own internal life support systems are starting to fail. The bleeding isn't slowing down because you're doing a great job controlling it. It's slowing down because the body is shutting down. And that right there is the key insight for today. In emergency care, context is absolutely everything. The exact same sign, a bleed that's slowing down, can mean 2 completely opposite things. It's such a powerful reminder to always look past the obvious. Which leaves us with this final thought to chew on. When is a good sign actually a warning?